Okay, today's lesson is going to talk about how to graph inequalities, and this is going to largely be review. So first of all, a couple of terms. We have to talk about the slope. And slope is typically talked about rise over run, where we're going to subtract our x-coordinates over our y-coordinates, subtract our y-coordinates over our x-coordinates. What does this really mean? If we think about a coordinate system, and you think about how much you are rising, isn't that a change in your y, versus how much you run, that's a change in your x. So you don't really need to have the formula given to you, you just need to understand what rise over run means. A couple of other terms that we talk about are the x-intercept, and that's where a line crosses the x-axis. It always has the form x, some number x, 0. If you think about every point on this line, it's going to be of that form. If we think about the y-intercept, that's where a line crosses the y-axis, it's going to have the ordered pair 0, some number. And if you think about all the points that live on that line, that is true. Now, standard form is just a name for the time when your x and your y are on the same side of the equation and your constant is over here. This form works best for finding the intercepts because you can let x equals 0 and you'll find y, and then you'll have the y-intercept, and then you can start over and you can let y equals 0, solve for x, and then you will have your x-intercept. We need 2 points to graph, and that is one method of graphing. Our other method of graphing is the one we are most used to, and that is the slope intercept form. And this is a very useful form. We always solve for y, and whatever the coefficient is of the x, that is your slope. Whatever your constant is, that is your y-intercept. So to graph from the slope intercept, you plot your y-intercept as your first step, and your second step is you count off your slope. And that'll take you to your next point, and then you can graph it. Remember that a positive slope is up or right. A negative slope is down or left. Now, when we're graphing an inequality, a lot of the same rules are going to apply. You're first going to pretend it's a line and graph it like a line. Then we're going to shade the region that makes the inequality true. So I'm going to use test points when I do this. And whenever possible, I use 0, 0. And what's going to happen in an inequality situation, also remember, greater than and less than, dotted lines, less than equal to, greater than equal to, solid lines. And we're graphing inequalities. So let's say I have this inequality that cuts through like that. In order to figure out where I'm going to shade it, this has really divided this into 2 regions, 1 and 2. Either this side and every point on it will make the inequality true, or this side and every point on it will make the inequality true. So if I test with 0, 0, and it makes my inequality false, that means every point on this side will make it false. So I want to shade this side. And that is how that works. Now let's look at some graphing examples here. Given the intercepts, that's the easiest place to start. Your x-intercept is 1, your y-intercept is 3, and you draw a mostly straight line. Here, I'm given it in slope-intercept form. So my y-intercept is 5. Do that first. This slope is negative 5 over 1, which tells me to go up 5, left 1, or I can go down 5, right 1. That negative can go in either way. Now, based on where I am here, it's easier to go down. 1, 2, 3, 4, 5, right 1, and I connect my line like so. Now, this next example isn't in slope-intercept form. So I need to solve this first for y. So I'm going to have negative 3y is equal to negative 2x minus 3. So I just subtracted 2x from both sides. Now I'm going to divide everything by negative 3. Remember to divide both pieces by negative 3. And I'm going to, with y is equal to negative 2/3 x plus negative 3 over negative 3. Remember how I like to change my sign here to plus a negative? Well, negative over a negative is positive. Negative over a negative is positive. So my intercept is 1, and I'm going to count up to 1, 2, right 1, 2, 3. Or I can go down 1, 2, left 1, 2, 3. And then my line will cut through like so. Well, this last example is one of those that kids remember this is either a horizontal line or a vertical line, but they can't remember quite which one is which. So you think to yourself, where are every single x coordinate equal to negative 4? And here's one place where x is negative 4. And if I go up here, that coordinate is at negative 4, 2. If I go up here, that coordinate is at negative 4, 5. This coordinate is at negative 4, 4. And so every x on this vertical line is negative 4. Now this is an equality. It was a less than or equal to, so I did a solid line. And now we need to shade which side of this, side 1 or side 2, is representing all the x's less than negative 4. Well, that's this side over here. That's where all the x's are less than negative 4. Now a couple more inequality examples. Here, my intercept is negative 2. Got that first. My slope is negative 1 over 2. So I'm going to go down 1, right 1, 2. Or I could go up 1, left 1, 2. This is less than, greater than scenario. So I do the dashed line. Now I have to test. So I'm going to pick 0, 0, and I'm going to put that into my original equation. So is 0 this will equal negative 1/2 times 0 minus 2. And I'm asking, is that inequality true? So is 0 greater than negative 2? That's true. So I shade the side of the graph that includes 0, 0 as an answer, because every point on this side will make it true. Now our next example over here is also not in the appropriate form. So I'm going to start with negative 5y is less than or equal to negative x plus negative 15. Now, when we divide by a negative 5, remember that key rule, and you will see I always circle, you have to flip the inequality. So I'm going to have y is greater than or equal to negative 1 over negative 5 x plus negative 15 divided by negative 5 is positive 3, and negative over negative is a positive. So I go to 3, I go up 1, right 1, 2, 3, 4, 5, or I can go down 1, 1, 2, 3, 4, 5. It's a less than equal to, greater than equal to type problem. So I have a solid line. Now to figure out which side to shade. So let's test again with 0, 0. We're trying to determine if that point right there makes it true or false. I'm always going to go back to my original. I'm going to say 0 minus 5 times 0. Is that less than or equal to negative 15? Is 0 less than or equal to negative 15? Well, that is false. So not only does 0, 0 make it false, everything on this side makes it false, which means everything on this side makes it true.